now we will go in little detail about this particular mode of heat transfer, convection. You already know the basic concepts of this, which we studied earlier as part of all three modes at the beginning of this subject. So now, if you pay a little attention to this equation which governs the heat transfer by convection, it is heat transfer coefficient, area of the surface over which the fluid is flowing, and temperature difference between the solid surface and the fluid which is flowing over it. Right? Now, for a given object, this area is fixed, and for a given surface temperature and fluid temperature. Now the heat transfer coefficient is directly proportional to H, heat transfer coefficient. So higher the value of H, higher is the heat transfer. Now, what are the factors or conditions or parameters that are going to actually influence this heat transfer coefficient? Broadly, they can be classified into three categories or three factors. Right? Number one, geometry of the body. Geometry or configuration of the body, which is exposed to surrounding fluid at different temperature. The second one is thermal properties. Thermal properties of the fluid, which is involved in the convection heat transfer. And the third is nature of fluid. Nature of fluid. Now let's take one by one. The geometry of the body, that means the shape, size and orientation of the body over which the fluid is flowing, whether it is a flat plate or a cylinder or a sphere or a tube bank, series of tubes connected in parallel. So that is the geometry or configuration of the body. See, why the geometry is important. For example, now this is a convective condition. Here we are in a room where the ambient fluid or surrounding fluid is air. Air is at certain temperature, right? That's fixed. And now this surface is, let us say, at some other temperature. Obviously, heat transfer comes into discussion only when the temperature of this body is different from temperature of the surrounding fluid. Let us assume it is at some different temperature, Ts, right? Now, let us assume this is put at any one point in this room. Now, the orientation of this body, whether it is kept like this in the vertical plane, or whether it is kept in inclined position, or in a horizontal plane, or at a certain angle to either of these planes, right? That is one way of understanding the geometry which changes or which may change. And also the shape of this object. This could be a flat plate like this, or this could be a cylindrical surface, let's say if it is pen, right, or maybe a spherical ball. So all these are part of this geometry of the body. So how does it reflect, or how does it actually how is it actually impacted by how this heat transfer is impacted, or heat transfer coefficient by this, right? This is one of the factors that contributes to it, right? So you can very easily understand now when it is kept like this. Now whether the flow is in vertical direction, up or down, then in that case maximum of the surface area is now exposed, right? So suppose for the same vertical motion of the fluid, if the plate is like this, now only edges are clearly touched by that fluid, but the top surface is not wetted or touched by that. So therefore the air which is passing over this, whether it is touching the entire surface or not, it depends on the orientation of the object that is put in place. So this you can imagine in many different ways. It also affects in many different ways, but for the time being, let us assume it as simple as this. That's the geometry of the body. Now thermal properties of the fluid. Now for the same object, in one case it is kept in air, in another case it is kept in water, right? The heat transfer rate will be different, quite obviously. The reason is this, right? The thermal properties of the fluid are, what are the thermal properties? Like thermal conductivity, thermal diffusivity, right? The heat capacity, C, specific heat, what you call it as, and the density. Right? These are all the properties of the fluid which will have the impact, right? See, I told this example earlier also. If you want to cool a cup of coffee or milk, right? One way of making it faster is keep it in water instead of in air. Because water has different thermal properties which will contribute to higher heat transfer rate. Right? Water has better heat transfer rate because of this factor. Okay. And the third one, nature of fluid flow. What is the nature of fluid flow? Suppose if you take the same case of our room where we are all sitting here, right? In the presence or in the absence of fans, rather the fan is working or not. Again, take the same case where you take a cup of tea and keep it on the top of the table. And in one case there is no fan, fan is switched off, and the other case fan is switched on. In which case the heat transfer rate will be better? The second case, right? When the fan is switched off. What's happening here? It has nothing to do with the geometry of the surface. It has nothing to do with thermal properties. But what is actually influencing? The motion of the fluid around it. Right? The faster the fluid is flowing across that object which is to be cooled, that will be coffee or milk or simply object, right? Let a solid object, let it be. So the velocity with which the fluid is flowing over it is actually influencing the heat transfer rate. Right? So similarly, the other parameters that come under this are whether the flow is laminar or turbulent. Right? So laminar is very smooth and orderly flow, whereas turbulence is it's the motion will be in different directions. In laminar it is one single direction, just like you imagine water is flowing in a river smoothly, right? That is a typical case of laminar flow. Suppose you create disturbance, right? You put heavy masses into it or throw stones, so then that flow is disturbed, that laminar flow is disturbed, and there will be a lot of cross motion. The molecules of water will move up and down instead of simply going in the direction of the flow. Right? So laminar and turbulent flow is one of the key factors which influences the heat transfer coefficient. So these three factors will influence the heat transfer coefficient and hence the heat transfer rate. Okay, please note them down. One important point that you should have understood is the fluid motion is influencing the heat transfer rate heavily, right? And repeating. Under the nature of fluid flow, the velocity with which the fluid is flowing over the given object or surface has great influence on the heat transfer coefficient and hence heat transfer rate. Now, there are two cases. Case one, where the velocity of the fluid is created by external agencies or external means or machines, whatever it is, like fans, blowers, etc. So in such a case, we call this as forced convection. Forced convection. If the velocity is created by external agencies like fans and blowers, we are trying to influence it with external sources, like it's not natural. Okay. Now, the other way of creating the velocity is because of the buoyancy effect. What are the buoyancy effects? Buoyancy effects is because of gravitational forces. See, let us imagine, this room itself. Why do we provide ventilators on the top? Why not on the bottom of the floor or wall? The intention is to force naturally or to induce naturally the hot air to go out. Because hotter air or any hotter object will be lighter, right? That density is less. How can you say that? I am giving a statement. Harder particles or molecules will be lighter. That means their density is lesser compared to the other molecules which are at lower temperature. How can you say that? How can you prove that? PV is equal to MRT. Right? MRT. When this is already specific volume, you can simply put it as PV is equal to RT. So V is specific volume. What is the relationship between V and rho? Density. Specific volume is meter cube per kg. Density is kg per meter. So V is 1 by rho. So this can be written as P by rho is equal to R into T. Now see this. This temperature and density are inversely proportional. Density is inversely proportional to temperature. So higher the temperature, lesser the density. See, after we sit here for sufficiently longer periods of time, then this air normally gets heated because of so many factors. Heat transfer from the surroundings, conversion of the mechanical energy that is produced by fans, lights, LCD projector, laptop, your mobile phones. All those energies are converted into heat energies. That heat is generated within the room, and we are all breathing, right? Lot of heat is coming out through respiration. So heat is again injected into the room. Because of this, the air gets heated up, and the hot air, because it is becoming lighter, its density is decreasing. It is going up, and there are vents, right, so that it can escape. So that's the reason. You might have seen this, even with your water. Whenever you heat it, on the top surface, if you see, it will be very hot. If you take your hand deep inside, it will be cooler. So therefore, it is possible to create that fluid motion naturally, wherein that is what buoyancy is, just like floating. Buoyancy effect is floating. So because of gravity, heavier molecules will be dropped to the bottom, right? And lighter molecules will be floated to the top. So this way, what's happening? A motion is created, fluid motion is created. Let's imagine there is a hard surface. Let's say instead of the bench, it is a hot metal plate. And imagine some air is flowing over it. And what it is doing? It is picking up heat from the surface. And thereby some of its molecules are getting heated, and their density reduces and it goes up. And all other molecules which are not touching the surface, they will go down. So likewise, a motion is created in certain order, and that motion is not because of fans or blowers, right? It's because of buoyancy effects and gravitational forces. So that kind of velocity which is produced or created, we call it as free convection or natural convection. Free or natural convection.